My name is Ivan Haigh. I'm an associate professor in coastal oceanography at the University of Southampton. And today I just briefly want to tell you about sea level rise and coastal flooding and to highlight a small selection of the work that my team and I are doing around the world in this area. This really nice image actually shows global warming from on the left-hand side from 1850 right through today on the right-hand side, and the colours just indicate the amount of warming. And you can see that over time we've seen a definite increase in surface warming globally, and obviously this is known as climate change. So we've been steadily heating up our planet, and 10 of the warmest years have occurred in the last 20 years. And actually, if you include 2020, which I think will pass all the records, then 10 of the warmest years will have been in the last decade. Now, as we've warmed the planet, it's causing a number of issues. There's less snow and ice. As those melt, there's more droughts and wildfires. We've seen that in California this year, in Australia. There's higher temperatures, stronger storms. But one of the most certain and probably one of the most costly consequences of climate change is sea level rise, and that's the area that me and my team work in. Now, as the climate warms up, it heats the surface of the ocean. That heat is gradually transferred into the depths of the ocean. As the ocean warms, it expands, and so the level of the water goes up. The land-based ice melts as well in Greenland and Antarctica, and that extra volume of water is added to the ocean, and glaciers melt as well. And all of that over the last 100 years has caused sea levels to rise. Now here I'm showing 3 of the longest tide gauge records that we have in the world, in France, the USA and Japan. And these records cover about 200 years in length. And you can see that sea level has risen, it's gone up and down, but over time we've seen that gradual increase in the rate of sea level rise. We've seen about 20 centimetres sea level rise, and that rate is accelerating, it's getting faster and faster. In the last 20 years, that rate has doubled. So over the 20th century, we saw about 1.7 millimetres per year of sea level rise. Now that rate has doubled to 3.3 millimetres per year rise, and this is the measurement of sea level rise we get from satellite altimetry. The average is about 3 millimetres per year, that kind of orangey-yellow colour. There's some regions where sea levels have risen a lot faster, up to 3 times as faster. For example, in and around kind of Indonesia, northern Australia, that region there, the Philippines. Now, as sea levels rise, there's 3 areas that are going to have a big impact. My team and I look at both the rates of sea level rise. We look at tide gauge records and satellite around the world to kind of understand that. But we also look at the kind of impact. So probably the region that's going to be firstly affected by sea level rise is small island developing states. There's about 58 small island developing states around the world, 28 in the Caribbean, 4 in the Atlantic, the majority in the Pacific. And small islands have something in common there. They're all very different, but they're small, they're remote, they have high energy costs, they're very heavily dependent on trade, they have expensive infrastructure administrations compared to their size. They're very fragile, physically, biologically, and chemically. Now, it's tempted to think the small islands look like this, but this is one of the most densely populated small islands in the world. This is Mali, the capital of the Maldives, and no part of the Maldives is above 1 metre sea level rise. So increasingly, we're going to start to see these regions affected. One of the places that my team and I have been investigating is Walandi in the Solomon Islands. This is what Walandi looked like 20 years ago. But a major storm in 2009 destroyed Walandi. This is what Walandi looked like 3 years ago. And this is Walandi today. That island is completely gone. More than 1,000 people have had to relocate from that island to the mainland. Other areas that we're investigating at the University of Southampton, my team and I, is deltas. Deltas are very low-lying, fertile lands where a river comes and approaches the sea. We've been studying the Mekong Delta, one of the most famous deltas in the world. On the left here you have population density. You can see there's about 20 million people live in this very fertile area. It's one of the largest rice growing regions in the world. On the right we have the land elevation. You see most of that land is below a few metres in depth. So as sea levels rise, these communities are becoming more and more vulnerable. They're often very poor people that live in these areas. And finally, one of the regions that's going to be most affected by sea level rise is coastal cities. There's more than 139 coastal cities around the world shown in this map. Closest to us, closest to me here in Southampton is London. My team and I are doing a lot of work about how cities can prepare for sea level rise. We're working very closely with the Thames Barrier in London. The Thames Barrier has had to close 197 times now to protect London from flooding. And it's been estimated the barrier and associated defences preserve about £2 billion worth of investment to London that wouldn't be there unless London was protected from flooding. So that's just a very short video, but just to give you an idea of the sorts of research into sea level rise that we do here in Southampton. Please do contact me if you have any questions. Thank you.